This is a rectangular loop conducting current I. This is the length. Is placed in uniform magnetic field B, which is perpendicularly directed into the plane of paper. This entire loop was in this field and I applied some force here and pulled this out. Now, when I apply force and pull it out, there are other forces acting on this loop. Now there is one force F1 which is acting in this direction, there is another force F2 acting in this direction, and there is another force acting in this direction. Alright, and I have pulled it in this direction with velocity v. Alright, now if you observe this and this, you would find that it's identical and opposite. So force F1 would balance force F2. So what force remains is F3. F3 is the force which would be pulling the rectangular loop that side. Why is the force in this direction? It can be proved by Fleming's thumb rule. Now let's apply Fleming's left hand rule to our coil, rectangular coil. Now we know current is flowing this way. We know that current is flowing this way. So this is the direction of current I. Alright, and we know B is perpendicular and into the paper, so it is down. So this is B, which is down. So now what remains is thumb, which is force, which is towards inside. Alright, so this is how Fleming's left hand rule helps us in finding out direction of force, knowing direction of current and knowing direction of magnetic field B. Alright, so this is how it is very helpful. So now we are sure that the force which is there is in this direction. As per Fleming's left hand rule, we found that the thumb was pointing inside, so the force was in this direction. And the rectangular loop that we pulled was towards this direction. So this force and F3 are in opposite directions. So we can say F is equal to minus F3. Alright, so this is the situation. So a loop, a rectangular loop in magnetic field pulled out with velocity v and force F, and the distance through which it has been pulled out is dx. The length is L. So the area covered while pulling it out is L into dx. L into dx is the area that has been pulled out, and then via Fleming's left hand rule, thumb was pointing inside, so F3 was directed inwards, whereas F was directed outwards. This is what we experienced. Alright, now let us get into some simple derivation. Now we know B, magnetic field, is flux over area, so flux is equal to B into A. D phi is equal to B L into dx. Why? As I explained, L into dx is dA. Now d phi is, we are talking in terms of small flux change. Alright, so d phi is BL dx. Alright, now what I do is I differentiate it by dt. So dt, dt. So d phi by dt in magnitude BL dx by dt. Now we know dx by dt is velocity. So the formula gets to d phi by dt is equal to BLV. Now d phi by dt we also know as per Lenz's law is minus E. So this d phi by dt, if I wouldn't have had magnitude, then this would have been minus BLV. Alright, but we are talking in terms of magnitude. So in terms of magnitude, E is BLV. Otherwise, E would have been minus BLV. Alright, now we know Ohm's law. Ohm's law is equal to V is equal to IR. So I is equal to V over R. So now what do? We want I. This was in terms of E. We want in terms of I. So magnitude of E divided by R. V by R gives you I. So we substitute this value. So we get yet another formula BLV upon R, where this R is resistance. Alright. When we have current, length and B involved, it's applicable for Lorentz force. Lorentz force is IL cross B and it is perpendicular. Angle is 90 degree. Alright. Mod of F3 can also be written as ILB sine theta, because we know whenever it is cross product, it is sine theta, and since the Lorentz force is perpendicular to L and B, so the angle is 90 degree, so it is ILB sine 90. Alright, now we already have proved here I is equal to BLV upon R. So we just substitute there this value. Now prior to substitution, what we do, we know sine 90 is 1. So the formula becomes ILB. I call it as BIL, BIL. That becomes very easy for you to keep it in mind. So ILB, that is force formula in terms of magnitude. And then what we do is we substitute what I was referring right now, BLV upon R instead of I. So the formula becomes BLV upon R and LB here. Alright, so it becomes B square L square V upon R is equal to F. So we get yet another formula for force. So we had a formula in terms of magnitude which was BIL, BIL. We got another formula which is B square L square V upon R, where V is velocity with which we have been pulling this out. Alright, that's the force. Then we also got yet another formula, I is equal to BLV upon R and E is equal to BLV. Alright, so these all whichever I have blocked with red are the formulas which are to be kept in mind with its proper understanding. Alright. So we saw formula for EMF, we saw formula for current I, we saw formula for force. Now why not check out also the formula for power? Now let's get into formula for power. So let's explore the formula for power. Power is work upon time. Rate of doing work is power. So work upon time is power. Work we know is force into displacement, and this time is this t, and we know S upon distance over time is velocity, so it becomes vector F into vector V is power. So that's one formula for power which we have got to keep it in mind always. Now let's modify it as per our way, induction and energy transfer way. Now power is F into V. Now we already got formula for F. We jot it down, B square L square V upon R. We derived it just now. Alright, we derived it just now. We just substituted there, and there is yet another V. So we multiply with that. So simple. So B square L square V square upon R becomes the formula for power. Now, if we move ahead, power is also I square into R. I current and R is resistance. This can also be proved via this. How? We already got a formula for I which was BLV upon R. Keep it in mind, this V is always velocity. BLV upon R. Alright. So isn't this, so can't we modify this as this? So it is BLV upon R the whole square, which is I square into R. In case you are confused, how could this be I square R? Just to prove it, now see, if we open this square, so it would be square L square V square upon R square and multiplied by R. So this 1R and 1R would get cancelled, and what we would end up with is V square L square V square upon R. Alright, and that's what the formula for power. So just to get in that format, we divided and multiplied by R to get this. So divided and multiplied. So what division was there, that got converted to R square, and 1 R remained here. So that was this. Alright, so P is equal to BLVR the whole square into R. Well, I'll make it very simple for you to keep these formulae in mind. If you check out over here, now this I am making it easy for you for numerical purpose. Now see, for B, flux over area. For magnitude, EMF, it is BLV, and for current, it is BLV upon R, and for F, it is B square L square V upon R, and for power it is b square L square V square upon R. Alright, so see, it starts with VLV upon R, then b square L square V upon R, and then b square L square V square upon R. So that's how you can easily by heart this formula and keep it in mind for your numerical purpose. And then this also we saw I square over R. Alright.